Welcome back to the lab, welcome back to EE for Everyone. Today we're going to walk through an important part of any project. We're making a prototype UI for our electronic load. We may very well end up tweaking this design down the road, but that's okay with me. I just need something that works. I need something that works well enough to use while proving that the overall hardware design is functional and, well, yeah, we're going to be using it a lot and you'll see it a lot in the videos to come. Okay. Speaking of, yeah, I'll put a card to the project playlist in the corner. Yeah, and a few relevant links down in the description. Make sure to check those out. That said, this project is all about information. This is meant to be a piece of proper equipment, and I don't like to be clicking through menus. I want everything at a glance. That is why we're going to use one of these awesome little 1-inch SSD 1306 I2C OLED displays. These little parts are great. We're able to cram a lot of information in one of these. We're able to cram some special options on the left to go with our option buttons. We're able to put a title on the top with just the perfect amount of room left over to display voltage, current, resistance, power, and total energy accumulated during that cycle. So that's great. And I learned there's different versions of these during this project. Fun fact, with the ground and power pin flipped, because apparently people are masochists and they don't want all of their I2C displays to work with everything. So that is a real shame. If you're duplicating our design at home, and I really, really hope that you are, because this has been so useful already. Like, this electronic load is already doing the one thing that my other one never could. I trust it. And it didn't explode. So there's that. Yes, let's walk through a few critical pieces of this firmware. One, first fact, it's running in the Arduino IDE, which I have mixed feelings about. I didn't want to reinvent the display driver library for one of these things, and it just works, and I love that. I really can't stand the Arduino IDE because it doesn't have a debugger, so things that should be easy to diagnose and solve become incredibly difficult and just riddled with print statements and all kinds of nonsense. Can't stand it, but that is okay. We're using the Teensy add-ons for the IDE, and we wrote an initial prototype GUI for the Atmega 328P, one of those tiny little 8-bit AVR Atmega 628P based boards. So we're using the Gryman SSD 1306 ASCII library for now. Has a lot of limitations, but it does what we need. It gets the information to me. Third, I wrote an object-oriented class in code, Mangled C++, and that handles one screen worth of information, and then another class handles the button inputs and switches between scenes. I've got big dreams for this UI and what I really want it to do. I want a baked-in tutorial walking you through how to use this when you first get one. I want a calibration routine that's guided and helps you to get the thing under control. I want slew rate control and advanced features and programmable electronic loads to be integrated into this thing. I'd love for graphs to be plotted on the device. That's possible. This is a graphic display, and I would love that. But all things in time. All things in time. Here's what we have now. This is our GUI. Welcome. And this is what you're greeted with. It's really quite basic. This is the dev board. There's only one channel, so if you push the channel plus button, well, it just stays at channel 1. There's no channel 2 to go to, but it would just cycle through all the channels. What you can do is you can come in and you can set a current. Press and hold, and that will attempt to run that current. Now it's displaying what's actually measured by the ADC, not what you have programmed. One click, you're back at the config menu, the output turns off. It allows for adjusting voltage, current, and power. Resistance, current, and power. Voltage is still there, but that is our little debug LED. And there's a little error state. If you actually attempt to run voltage, it gives you the error blinky instead of the run blinky. So, yeah, I need to lock that out in hardware. So there's 3 real states for the LED right now. There's idle, this is idle, there's run, and then there's error. But obviously, you can make as many patterns as you want to indicate whatever it is you want, and that was kind of the purpose of
this tri-state LED implementation just adds a lot more options. But yeah, so I'll get some power plugged into this thing, and I'll let you just see the readout. I'll set the current down around 0.5 amp, sure. And then once you set that set point, once you're in run mode, the GUI changes from showing you set points to measured values. This thing actually does internal power limiting, current limiting, and voltage limiting in both software and hardware. It attempts to enforce the design limit in software, and then if it's exceeded by some amount, the hardware watchdog will kick in. I think right now the reason why we didn't hit our full current is actually because of that. No, that's just where we're at. I turned down the input voltage and the current remains solid. But as a demo of that, I'll just come in here, set the current to something ridiculous. Oh wait, that might actually work if the voltage is too low, because the load can pull in more current than the load can supply. So you can see we're pegged right against the currently programmed power limit, which is 53 watts, kind of bouncing around there. But even though we set it to current mode, and I do intend to add some indication, but basically the electronic load just silently clips to whatever it cannot achieve. So even though we asked for 11 amps, the voltage is high enough that it hits the power limit of this cooling solution first, or at least the perceived power limit. It's not totally tuned yet, so there's more to come, but that is where we are at. And just for fun, I'll reset the UI so you can see the beautiful, beautiful splash screen that we've added.
So that is our UI. It is certainly not perfect. It is a little ugly, a little rough around the edges, but I love it, and I'm a hardware engineer at heart. Normally, we only release the full designs to Patreon members, but this electronic load is simply too good to keep for myself. This design isn't dangerous. It's incredibly useful for people just getting started, or not. It's really useful. It's an electronic load, and it's way cheaper than a typical electronic load, which is awesome. So if you're anything like me, if you do projects and you need an electronic load that just works when you need it to work, and it has ratings and it meets those ratings, this is not going to be a 500 volt electronic load that blows up when you try to run it at 250 volts. This is going to be a 100 volt rated load that works up to its full rating at 100 volts. At least that's my intention. That's part of the reason why we as EE for Everyone, the online learning community, are trying to coordinate future development of this firmware through passionate members of the community more educated in software than myself. We'll be releasing a community edition of a modified version of this hardware for everyone to build, and if I can turn it into a kit, I'd love to do that. Never done that before, but these things are great, and I want to make sure that you can get one in your hands. So if you're in any way interested in helping out with a project like this, if you have some experience and you want to lend a hand, reach out to us via Slack in our Patreon Slack channel, or reach out to our Business Inquiry email on YouTube, and I will be happy to triage those volunteers. We're just trying to get coordinated. It'll be all managed through Git. But yeah, if you've got experience in C++ or Python, definitely reach out. If you like this video and you can't wait for more, let me know by getting subscribed, hitting that like button, or leaving a comment down below. Coming up soon, we'll be trying to control this electronic load via PC application and walking through our first tests, including transient response, regulation performance, and thermal results. I cannot wait. If you want to support the channel, don't forget to check out those links. There's one to our Patreon page down below, as well as some other good ones. That really helps us a lot. Thank you to everyone that took that step of supporting us on Patreon. I appreciate you, and you keep this all possible. Most of all, I hope that you learned something great today, and I hope to see you again soon. Thank you for watching Eat for Everyone, and thanks for staying till the end. Bye!